Hi everyone, welcome to another episode of my R for Bioinformatics class. In this video, I'll show you how to visualize phylogenetic trees using add map to it. So that's what we are going to do. So before I proceed, let me say that the command that I'm going to use, the R codes, everything has been packaged into an R script. So if you want the already packaged R script or the codes, check the description box, the down link, the R script there. But we are going to look at these codes line by line and I will everything. You need to make sure that you have R installed and you should also have these packages installed. These are the requirements. R, if you have it installed, so have these packages. You can run this tutorial on Windows or Linux. Any of them is fine. Take note of that. So without further ado, let's get started. So first of all, we need to get our data. Then we proceed. So I have the data available on one of my GitHub repos. So let's look at how to get the data first. So what we need to do is to visit this GitHub repo. The link to this repo is in the description box. I repeat, the link to this repo is in the description box. So when you are here, you need these two. We have the data.tree, that's the phylogenetic tree. We also have data.values, what we are going to use to generate the heat map. So when you are on this page, download them one by one. You can start with this one. So click it. When you click it, you send to another page. Okay, you see something like this. So what you need is to get the file. You can come to this download button. This will download the file for you. Click it, download it. Downloaded. Now you also need to get the other file. That is data.values. Let's get back to get this. This is data.values. This file we also need. So click it. When you click it, you'll be sent to this page. Again, just comes to the download button here. Download it. These are the inputs. So let me also get to this page first. What page? Let's where the files can be found. And then let's do a couple of things. Okay. So I have them here, but I would like to organize them a bit. So I would like to put them in a different folder and then that. I'll first create a folder. Let's say of phylogenetic trees. It should be descriptive. So let's say phylogenetic trees. Okay, I'll put it this way. Then I'm going to move the files in that directory or folder. So I'm going to move them there. It's a way to organize. I usually recommend that whenever you are starting a project, you always have a folder for that project alone. So that is why I'm doing it that way. So I have that also here. Okay, so this is the folder which has the files that we are going to. Okay. So this is the tree. By the way, so this tree, if you have your own data, or let's say if you plan to do something like this, you need to first make sure you have your phylogenetic tree already generated. You can use tools like RaxML. There are a couple of tools you can use to generate phylogenetic. There are also online tools that can help build the phylogenetic or construct them, right? So RaxML is one popular one. There's FastTree. There are a couple of tools that can be used to generate or to build a phylogenetic tree. So I've covered one such tutorial which I used RaxML. So you can check the description box for that if you want to learn how to generate a phylogenetic tree. So after that, if you also want to add extra data, then this is where this one comes in, the set of values, right? But first, let's even open the phylogenetic tree. This one, I believe, is in the Newick format. That's what you see. When you open it this way, it might not make sense, but when you visualize, then it becomes easier to interpret. So this is the tree. Now let's get back to the data that we are going to add. So this is it. I can open it with a spreadsheet software. Let's just try this. I just installed this, so I'll just have to do a couple of things. So I'm using this office to open it. It should open very soon. Okay, so this is the data I'm going to add. Data I'll use to generate the heat map. So if you're going to generate the heat map, you need to make sure the labels here are the same as the ones you have in the tree. That's very, very important. So the samples or the labels in the tree, they should be the same as what you have here. So it's very, very important. Take note of that. Okay, so that's it. And the data, it can be any data. Okay. So for example, if let's say you are dealing with, let's say, bacterial genomes, then you can have table that has maybe antimicrobial resistance profiles, or maybe have maybe measurement from experiments. You can put them in this. This is how it should be done. So you have your labels for each column, be a form of measurement that you have to use. So for the design, that one I'll leave it to you, but this is just to explain or to show you how to prepare your data so that you can just use them to generate your plot. I have something like this. And for those who still want extra tutorials, you can always contact me for extra tutorials on how to do some of this. So that's what you need to take note of. I think I'll be making more tutorials of such nature where I focus on project-based stuff. Okay. Stay tuned for more of such tutorials. Okay, so let's proceed. So I have my data, I have my phylogenetic tree, which I showed earlier. Yeah, this one here. So I have both files, so we are good to go. Okay, so let's do this. Now let's open R. You have R and R Studio also installed. I have mine here. So this is R. So what I'll need to do is to click on new scripts. So I come to file and I click on this one here, new file, and I come to R scripts. So like this, I'll click it. Once I click, I'll have this coming up. That's what I. All right. So I'll also do this. Let's say I'll try to increase the font size a bit. It's important that text becomes visible. I'll do it this way. Perfect. So I think this is better now. Okay. I'll do a few adjustments here before we start. This should be fine now. Okay, good. So now we are ready to start the exercise. All right, so what we will do first is to load our packages. It's very, very important. So I'll start with this one. I'll say library ggtree. You should make sure you have installed it. Now ggtree is what we are going to use to generate the tree, or let's say to visualize. It's used for visualization. The generation is different from visualizing. So this R package is what we are going to visualize, what we are going to use to visualize the phylogenetic. So we need to make sure we load that library. We need to load that. Then we also need ggplots 2. This is also used to add some additional visualizations, or let's say add additional properties to vary the appearance of plot. I'll put it that way. So if you want added functionality, you can add ggplot2. So we're also going to load that one here. And lastly, we are going to load this library, our color brewer, which is also used for designing, or for, yeah, let's say for designing color schemes, basically. Okay. That's our color brewer. Okay, so these are the R packages we are going to use. I think I have them all in my browser. So this is ggtree. This is the page. I'll leave the link to this page in the description. We are following this particular one here. Plotting tree. We also have the gene heatmap function, which is in ggtree, by the way. I'll leave the link to this page also in the description. We also have this one, which is, I think it's an inbuilt R function. But let's go to R color right? So this is the page. We also have ggplot as well. So basically all the useful links that you need with respect to this tutorial is available. So all of them are going to be found in the description box of this video. Take note of that. So we are following the documentation here. So here it's very extensive, but I picked just a few. There are different visualizations here. We have code. You can read more half time, but I'm focusing on just aspect of which is the heat map. But you can also do much more. So just take note of that. Okay. By the way, I have a separate tutorial where I showed how to also visualize Phylogenetic tree with ggtree. So that one was pretty extensive because I had to cover a lot of stuffs. So if you want a detailed tutorial on generating or visualizing Phylogenetic trees using ggtree, that video will also be very helpful. Now let's get back to our exercise. Okay, so these are documentations. Let's get back to R and then start. Okay, so I'm here. I've loaded all my packages. Okay, so after loading the packages, then we also need to set a path to where our data can be found and set that path. So I'm using a Linux system. I know my path is going to be /home/ I know the path of it, so I'm going to set that in R first. So I will say set wd and I'll give the path. So it's /home. So this is my path, a working directory. This is where files can be found. So I'm setting it so that I'll be able to read the files without using the absolute path. And I'll also be able to save the output that very same path. I can even find it on the right side here. It's somewhere also. That's it. So I will set the path first. That's the working directory. Set the work. So I'm going to set it. Right. So now it's time. I also need to define variables for the tree, the input files. So the tree file, right, is equals to data tree. This is it. Then we also have data. Let's say data, or let's say heat up data. Okay, and that will be data.values.csv. This is it. And the reason why I use this and this without the absolute path is that I've already set my working directory to the path or to the folder which has those files. So that means when I'm defining, I don't need to bring the absolute path again. All this here / this. Once I've set it, it's like I've already moved into that directory. So I only need to call the file by their names and then it will be fine. So that's how we do it. Now let's proceed. So now what we are going to do next is to read the tree information. All right. So I'll just say P. Then I'll say read dot tree. I'll say tree file. So I'm going to read it. Right, that is done. Now I'm going to plot the tree. So I'll say, let me just say plot the tree. So I'll say my tree, and that'll be ggtree. then the tree objects. Then here you can add some customizations to it. So I'll just say size equals 1. You can change it, say branch.length equals, I want to use this. And let me say that for a detailed explanation of all these things, check my other video on ggtree. So for that tutorial, I explained a couple of things, but for this tutorial, focus show how to visualize with Heatmap. So those details, I'll only explain the necessary ones here. Is it? So it's very, very simple. But we'll add something else to it. So say plus lab. We're going to add this to it. So we have ggtree, specify the P, which is the tree object, the one we read here. Then after that, we say size equals 1, branch length equals none. Add this other so to it. Again, for a detailed explanation of these things, check my other video on ggtree. The link to that video is in the description box. Okay, branch length, you can also change it. I mean, these things you can change them depend on what you want, depend on how you want your tree to appear. So those things, I'll leave those options to you. So check the ggtree documentation. So let's run this to generate the tree. So now the tree has been generated, right? So we are good to go. Let's continue. We are all doing a good job here. Okay, now we need to also do this. We need to read the heat map for that one. I'll just say df. Okay, I can say df heat map. Okay, so the names should be descriptive ideally. If you have variables that describe what the data is, I'll just make sure you do that. Or let's keep it simple. Let's just say df for data frame. That will be better for all of us. Let's keep it simple. So df is for data frame because we are going to read it like that. So df, I say read.csv. I'll say heat map data. So df read.csv because I specified it here. This is the variable. So heat map data, comma, and I'll say row dot names equals 1. We are going to read it, right? So let's read it. Okay, that has been done. So here you can even do a bit of exploration. I can say dim df just to see what I have. If I can say df itself and run it, you can get this table here. That's what you have here, right? So they have the heat map data also imported, so it's available. So now it's time to plot. So I'll just do this. So plot the tree and heat map. So to plot the tree and then the heat map, we use Heatmap. It was just the tree, a different approach, but here we are adding the heat map. So Heatmap. And we specify the tree, the one we generated using ggtree here. So the name is my tree, comma, and then we add the heatmap data, which is here df. We read it into a data frame, so it becomes df. All right, like this. So now let's run it. Perfect. So now we have it generated for us. So it is here. This is what we have. This is the tree. All right. Okay. So now we can proceed. Now, if you look at this tree, right? let's check the tree labels that are here. Ideally, all of them should be visible. This is what we have. If we take a look at the heatmap data, these are the labels. So let's get back. We see it also here. And then when we come to this plot here, it's not that visible. It's like it's hidden. It's behind heatmap itself. So there's a way to correct this. So in the next step, what we are going to do is to increase the space between the tree labels and the heatmap. Okay, so to do that, we still use heatmap. Specify the inputs, the mandatory ones, comma, and then we add what you call offsets. Okay, so we add offsets. I'll say offsets equals. They can modify it as you see fit. Let's try with 1. Let's run it. Perfect. So if you try with 1, this is what happens. You see it here. Now you will see that the space is large, or let's say, depending on what you want, it can be large. You can still increase it further. But I will want to close the gap further. So what I'll do is to rather reduce this number here. So I can say 0.7. And I'll run it. You see that gap is close enough. I will say 0.5. Let's try 0.5. Let's see. So 0.5. Let's try it. See. Okay, good. So these values, some of these values, it's more of experimentation. There is no best number. Okay, so you have to experiment a bit until you get the right value to use. Okay, so take note of that. With R Studio also, sometimes it also boils down to the behavior. For example, when you stretch this one, you see that the space has. When you do this, when you try to make it smaller, and when you also go to zoom, the appearance also differs a bit. So sometimes too, it may not be the number itself, but then it may be due to behavior of our students. So you may need to check all these things to ensure that. So for the rest of the manipulations of the plot, I'll leave that to you. All right, now it's time to proceed. So what we are going to do next is this. Now, if we take a look at this heatmap tree, sometimes your text, or let's say the labels, they may be longer than this. So what it means is that you may have to change the angles for the columns. This ones. So you can tilt it a bit so that if you have a longer text, all appear nicely. So for that situation, we use what you call the column names angle. So let's do this. Let's say change the orientation of heatmap columns, i.e. column angle. It's possible to do this. So again, we use heatmap to specify my tree df. Let's continue using the offsets. Then what we add is column names underscore angle. This one here. Then we can give an angle. So here I'll say 45. Right, so you can do it like this. So when you run it, first look at what is here and let's run it. So you can see that it has changed. Have it this. So you can make it 90 degrees. Depending on what you want, you make it 90. That's up to you. So this one too, I'll leave this to you. So I'll leave that to you too. Is that how you want it to be? Or you can also consult with help you get the right and the right orientation. Then use that for your presentation. So it's always important to consult. All right. Now we know these things. Now let's proceed. Now we have been using this color scheme. It's possible to change the color. Okay. Let's say the color range. Maybe you want maybe between green and blue, between blue and yellow, etc. It's possible to change that also here. So let's look at how to do that. So change the heat map color range. So it's possible to do that here. So here I'm going to show you 3 approaches for doing this. All right. So let's start with approach 1. In approach 1, we are using the inbuilt heat map options. That's the approach 1. Okay, so the inbuilt heat map option. Okay, so with the inbuilt one, we modify everything in the ggheatmap function itself. So let's try that. Let's try that here. We're going to do that now. Okay, so for that one, we still say ggheatmap doesn't change. We specify the tree df. Let's maintain the offset 0.5, comma. And then here we specify what you call low and high. Okay, we specify low and high. So where low means the color that should be given to low values, and high colors, or let's say a color scheme that should be given to a high value. So here I'll use blue and white. So low, I'll say blue. Then high, say white. The colors, again, I'll leave the options to you, right? So that's what I'm going to do, right? So here I'll run it. Then let's see what happens. Okay, great. So now you see that it has changed. We now have something like this. So you can modify it. If let's say you want the high to be yellow, up to you. You can also run it. Depends on you. So the colors, it's up to you. So you decide what you want it to be, right? So just make sure to also consult if you have someone who is good at color combinations, or check what has been used in publications and pick the one which you think is good. All right. So there's approach 1. Now let's look at approach 2. So approach 2, we are going to use the color ramp palette function, right? I earlier on showed that. Let's get back to page. We are going to use this function. Now with the ggheatmap to the options are here, by the way. That's the low and high. The default is green and red. That's what, but we changed it. There's also this one, but anyway, just explore. Okay. Now back to our color. So we are using the color ramp palette function. That is approach 2. Okay, so there's the page. Again, the link to this page is in the description box. So let's get back. So for that one, I'll say ggheatmap. Again, my tree df offset equals 0.5. All right. Now let's do this first. I think I'll hold on with this first. Okay. So let's do this. So for the color ramp palette function, what we need to do is to first define the colors that we want to use. Okay, so to define the colors, what you need to do is to first say, let's say colors, or let's say color range, or you can even say heatmap color range, and we say color ramp palette, this function here, and then we add the color. or colors. Okay, so here I'm going to use 2 colors. So that means they should be in vectors. So inside this, I will say C brackets blue, follow, and white. This is what I'm going to use. Okay, these are the colors I'm going to use. Just close the spaces. So we are going to have this. This is what we are going to use. This is the color range. Okay, so this is the first step. So let's run this. And then the next step is to now give the range itself in terms of numbers. I can say the colors will be what? Heatmap color range. I can give a value. So here, then the values you can decide, you can experiment based on the visualizations that come up. Okay, so here I'm using 5. Okay, so I'll run this, then that will give me my final color scheme. This is what I'm going to use. So now I can plot. I can say G Heatmap my tree df, then offset for 0.7. All right, I'll have it like this. Then I'll add it as a ggplot scheme. Okay, so when I come here, I'll have to say plus, I say scale fill gradient n. Right, like this. I'll say into brackets like this. I'll say colors equals. I'll say my colors, the one I did here. Okay. So that's how it's going to be defined. So let's run this. Perfect. So now we see it here like this. So this is how it's going to be. Now with this plot, once you do it, you will have this notification coming up, but you can ignore it. It's only telling you that something has been updated, but it's fine. It's nothing to worry about. So again, you can change it if, let's say, you want a say green, let's say this color, you can just run, then get it also done. So it depends on you. At the end of the day, the colors that you choose depends on. Let's say here you want it to be red. Great, you can just do it, then rerun. So the colors, again, I'll leave that to you to decide. Okay, so that is for approach 2. Now let's look at approach 3. So approach 3, say using our color brewer. We earlier on loaded that here. So we are going to use the R color brewer here. So to define our color scheme. Okay. So for that one too, we will define it. So I'll just add it here. Let's see how that is also done. So let's do this. Let's see how that is also done. So we will proceed that. All right, so let's look at how that is also going to be done. Okay, so again, I'll define my color and use it. So I'll say, so I'll say my color scheme. And I'll define the color here. right? So this is how the color is going to be defined. So I'll just say R color brewer. Okay, so you have to type it, okay, R color brewer, and then you bring 2 colons and you say brewer dot pl. I think the pl is for palettes, color palettes. So brewer dot pal, then you bring your number, that's the range, comma, and then find your color. So I have YL for yellow, GN for green, EU for blue. I believe that's how we have yellow, green, and blue. So we have something like this. All right. So this is what we are going to use. So we have defined it. So let's run it. Then we can call gene heatmap. Say my tree, df offsets equals 0.5. Okay, you can, the number I repeat, you can find what number is appropriate for you. So we have offsets like this. Okay, close it, or if you want to change the angle to, you can add it. Okay, offset equals 0.5. Then plus again, we are using this scale. So scale gradients n colors equals my color scheme like this. So let's execute this command. Nice. So again, we see the color change. Okay. So it's very, very nice. So you can just manipulate things like this. All right. So we have that also done. So these are the 3 approaches. And there could be other ways to do it. There are other ways. Okay. So just check the documentation on gene heatmap and see how to define colors. So there are different approaches, but I thought I'll let you know these 3 ones, which are also common and easy to understand. So again, you have to always experiment with the colors and see which one works best for you. Okay, so it's important to do that. Okay. Now you will notice that here, the legend, the text here is value. But in the table that I showed, there is nothing like that. Okay, so these ones, of course, they are values, but then sometimes you may want to use different name. Let's say we want to specify, let's say, condition, or maybe it's a profile, something like that. Then, or let's say count. Then, all the more reason why you also need to learn how to change the legend's title. Okay, so legend title, we are also going to do it here. That will be the last thing I'm going to do. Then, so we do the, let's say, change the legend title. So again here, I'll give 2 approaches. So approach 1, okay, using the inbuilt gene heatmap function. All right. So here we say gene heatmap my tree df offsets, let's say 0.7. Let's use 0.7. Okay. Then you say legend title equals, here you can define your title. Okay, so let's say condition. You can use condition, profile. Okay, let's say count. Okay, or give the specific. Let's say count. Okay, I'll use lowercase. Or let's say condition. I think condition will be perfect. Let's say condition. Yes. So once you have it this way, you can execute it. When you execute it, you will see that it has been changed. You see that here. So we have condition. can try, let's say, prefix profile, or let's say count. Let's even use count. It will also be there. So depends. It depends on what you want to put there. But this is the way to do it, right? So again, since it's the ggheatmap function, you can also define your low colors. Then try to customize it a bit more. So this is one approach. Now let's look at the other approach. Approach 2. Okay. So approach 2, this is how we do it. All right, so in approach 2, specify the legend in the scale gradient function. Okay, so for that one, if you do it, that one is useful if you're also customizing a color, right? So let's do this. So to do that, we say ggheatmap. Let's move this first. So to specify the legend in the scale fill gradients end function, we say ggheatmap the same. My tree df. Let's specify the offset. Okay, so here we don't add a legend title here. When we come here, say plus and say scale fill gradients, and let's make sure have it spelled correctly. This is a gg plus function by the way. So we have it this way, and then we define want to add colors. Let's say colors equals my colors, and then you bring your legend title here. Okay, so here we say name equals. You can add your legend title. So let's say legend, and let's just use legend, right? So we have it like this, and then you can execute it. I can see what's the legend here, title. Let's modify it. Let's say count, run it. So you see that also. So that has also been done nicely. So these are things you have to. That's okay. So again, let's try something else. Let's just change the color. Let's say blue. Let's say white. I'm going to just change the colors again. I'll just run this to change the color, and then I'll run this again. Get it. Have it this way. So with these things, there's so more you can do, okay, in terms of manipulating, in terms of adding other information, that features. These are things you can do. So the gene heat map is pretty extensive, so you can try to read and then see if there's something else you want to add. That would be great. So just do that. Make sure you are okay. All right. Now let's get back to it. Now you have your plot. How do we save it? There are a couple of ways. So first approach, once you have it in RStudio like this, you can just right click, save images. Let me go over again. Right click, save images, save it. Let's just save it. Let's say tree. I'll just let's try it. Yeah, I'll just save it. Let's say one. So you can give it any name. Let's say tree 1. Okay, so any name is fine. So once you save it, get back there, it's just open it. Here's how it's going to be the same as what you saw in the R Studio. That is one. Another approach is to come to zoom. If you want to zoom it, you can click zoom. Then you have it like this. Again here, and right click, go to save images. Then you save it. Have this notification. So here you can say let's say tree 2, or let's go to the same folder. Tree 2. But here you will have to add your extensions and all that stuff. So let's say tree.png. Unlike the other one, which automatically added that, you have to do everything. Save it. So again, this is tree 2. Open it. There's it. So this one seems to be larger compared to this one. So you need to know how to do it. That's another approach. Also, you can go to R Studio. Let's do this first. You can go to R Studio. There's an export here that to save. So you can save it as PDF or as just focus on image. I'll just save it. So again, let's say tree 3. Here, the name is fine. The format will be automatically saved or added. So I save it. It's also here. So it's here. I'll open it. Let's see how. So I think this one is similar to the tree 1. Let's just enlarge it first. This is also kind of similar to. Okay, so this is another approach. And also ggtree also has an inbuilt option for saving. There are other ways to save images, but this will be the last one. You can just say save plots. Okay. Using ggtree. Okay. So you can say save. Let's say output 1.jpg. Okay, something like this. So just save it. And when you save it, it will come. There's it out. There's it. That's it. Now for the saving, let's go back. For the saving, you can also customize it. All right, let's say save. All right, let's say output 2.jpg. Let's say you want to change the dimensions. You can add it here with, let's say width equals, let's say 20, height equals, let's say 10. Then here you can say limit. You have to add it if you are specifying width and height. So limit size equals false, right? Something like this. Also save it. I need to make sure you are using the right options. Okay, so it has been saved. So you go to output 2, it is there. So that one is also like this. So all of these things you can try and then decide which image best suits your needs. Now you need to do your position. So this is it. So with R, it has lots of packages for visualization, which include. So you should make sure to learn it. Now, for those who want extra tutorials, or if you have a data which you want to visualize like this, you can always contact me or book a session, and we can proceed with the rest of the activities. Okay, so that'll be all for this tutorial. And you should also check this playlist for more tutorials for beginners and for bioinformatics activities.